Welcome everyone. In this video, we will do a proof about divisibility rules. You might be wondering what exactly a divisibility rule is. So let me give you an example. For instance, if we have the number, 837, and you are wondering if this number is divisible by 9. What you do is you add up the digits of our number. So you add 8 plus 3 plus 7 and you have 18. And then you say, is 18 divisible by 9? And of course it is. So you conclude that this number right here is divisible by 9. This is an example to a divisibility rule that is called divisibility by 9. But what I want to do today is I want to give a more general rule which we can use to show that the rule for divisibility by 9 is just a special case of the general formula. So let's start doing that. And to do our proof, what am I doing? Okay. To do our proof, we first of all decide to have a number like this, A, B, C. And notice that this is not A times B times C. This is a 3-digit number. Alright? This is not a multiplication. And to make our proof even more general, I want this number to be in base n. So we are not in base 10 like we are in most of the time. We are in base n. Okay? So how can we find the value of this number in base n? Well, since we are in base n, the digits have values as follows, right? For example, if we were in base 10 like we are in most of the time, if we had this number, we would say this digit has 10 to the power of 0 as its value, 10 to the power of 1 and 10 to the power of 2 respectively, right? So it is not different. We just have n this time so that we have a more general result. So now I write what we have. I am just multiplying the value of the digit with the digit itself. I am multiplying the digit with its place value. And this of course gives us n squared a plus nb plus c. And of course this time these are multiplied. This isn't a 2-digit number. It might be a 2-digit number, but this is a multiplication in this case. Okay, this is n times b. It is not like what we had at the beginning, which was a 3-digit number. So here we go. And what I want to do is, I actually didn't say, but it's kind of weird that I didn't mention what we are trying to do at the beginning. But what we are trying to do is, we want to find the divisibility rule for n-1. That is what we are trying to do for n-1 in base n. So, and of course you can see where this is going because we are using base 10 in most of the time, and 10 minus 1 is equal to 9. So if we are able to derive this equation for base n, then by substituting 10 for n, we would get the divisibility rule for 9. Alright, so what I want to do is I will modify our equation a little bit. I subtracted the 1 from the coefficient of a, so I will add a here, and I will subtract a 1 from the coefficient of b as well, and of course I will add a b so that We don't change the value of our expression. And I won't do anything to c. And now I want to factor this part. Actually, not factor, I want to expand this part. And n squared minus 1 expands like this, n minus 1 times n plus 1. We, of course, still have a plus n minus 1, b plus c. All right. And now we will do a factorization, because we noticed that in these two terms, n minus 1 is a common factor. So we factor it out. We factor n minus 1 out, and we have n plus 1 times a plus b. Then we have plus a plus b plus c. So what I want to do now is, I want to call this term term 1. And I want to treat these three as one term, which we can do, and I will call it term 2. Now, if you notice, term 1 has n minus 1 in itself. So if we divide term 1 by n minus 1, we would get 0. It would be divisible by n minus 1. This means that in order for our number ABC, our 3-digit number ABC, to be divisible by n minus 1, we need our term 2 to be divisible by n minus 1 as well, because as I mentioned before, term 1 is always divisible no matter what value we give to a and b, right? Because it has n minus 1 already. So this means that ABC modulo n minus 1, and this mod here, it just means dividing by, okay? So this is, you can think this as a function, as an operator that gives you the remainder of a division. So for ABC mod n minus 1 to be equal to 0, in other words, for ABC to be divisible by n minus 1, this is possible if and only if the modulo of a plus b plus c n minus 1 is equal to 0. This is the only case, because as I said, term 1 is already divisible by n minus 1. So if term 2 is divisible by n minus 1, then our number ABC is divisible by n minus 1 as well. And this is it. We proved the case for divisibility by n minus 1 in base n. So let's see how this gives us our formula for 9, divisibility by 9. Well, for 9, we just say that n is equal to 10, so n minus 1 is equal to 9, which means that what we do here is we add up the digits and we check if it is divisible by 9. All right, that was what we did at the beginning, and it is, you could do a proof for 9 specifically as well, but it is very similar to the one we did with n. And the best part about our proof is that you don't need to limit yourself with the case that n is equal to 10. You could say, let n equal 23. And what is the divisibility rule by n minus 1, in this case 22? Well, all you do is you add up the digits of your number, and if it is divisible by 22, then it is, the number itself is divisible by 22 as well. And one last thing before ending this video that I want to emphasize is, notice that I used a 3-digit number in my proof, And if you were to use a 4-digit, a 5-digit, or even n-digit number, the results wouldn't change. And it is actually a very similar thing. It is actually very easy to see why it wouldn't change. If you're not convinced that the results wouldn't change, you can go ahead and try to do it yourself. As I said, it is very similar. I just wanted to keep this proof short and clear. That's why I chose 3 digits, because 2 digits would be very little and 1 digit would be, well, it wouldn't make a lot of sense in my opinion. So this is it. I hope that you found this video helpful and enjoyed it. If you have any comments or suggestions, please do not hesitate to ask them in the comment section. I hope to see you in another video. Until then, take care.